Hello everyone, today I will discuss about the how to solve infinite network circuit. Means if the circuit is infinitely long, then how to calculate the equivalent resistance. So let's start with how to solve the infinite network circuit. Suppose if I give this type of circuit which is infinitely long, how to find the equivalent equivalent resistance in between A and B. First rules is, there are certain rules. First rules is the find a repeating unit. What is the meaning of this repeating unit? Means see 1 and 2, 1, 2, 1, 2, they are repeating. So these are the repeating unit. Now after finding, the second rules is except the first unit. Except first means this 1 and 2, take the remaining part. Okay. Except 1 and 2, take the remaining part. So this is also infinitely long. This is also infinitely long. So let consider. So except first, take the others. These are the two rules. Now let the equivalent resistance is X. Means for which one? For this infinite network circuit is X. So what will be the circuit after that? This is 1, this is 2, V and A over here, and this resistance is X. This is 1, this is 2. Okay. Now see, this X and 2 are parallel. So our parallel will be how much? 2X divided by 2 plus X. Now the equivalent, R equivalent equals to this one and this are connected in series. So this will be R plus 2X. X I am writing over here. Suppose this is X divided by 2 plus X. Okay. Now one thing you see, this R equivalent is the total equivalent resistance of this infinite network circuit. So what will be the value of R equivalent? See, here this is infinitely long, that's why I have taken here X. So if you add some quantity with infinity, then this will be infinity also. So if here I have taken the equivalent resistance of this infinite circuit is X, so this total will also be X. Okay. Now this is X equals to 1 plus 2X by 2 plus X. Now solve it. Here I am solving. So we will get here X equals to 2 plus X plus twice X divided by 2 plus X. So here 2X plus X square equals to 2 plus X plus twice X. Okay. Now twice X cancel from each other. So X square minus X minus 2 equals to 0. So you see, from here we can write that X square minus twice X plus X minus 2 equals to 0. So this will be X, take the X common, X minus 2 plus X minus 2 equals to 0. This will be X plus 1 into X minus 2. So easily we can say this X cannot be equals to minus 1. See, here it is coming X equals to minus 1 and X equals to 2. So which one will we take? That X equals to 2. So the value of this resistance is X equals to 2 ohm, means the equivalent resistance of this infinite network will be 2 ohm. Understood? Now see, one different type I am telling. If the battery is connected over here, then suppose one battery is connected over here, the potential difference is given 4 volt. If the question is find how much current is flowing through 2 ohm resistor, how to find? Before that, Those who want to write, please write. Okay, let's go. Now, the current through 2 ohm, I 2 ohm equals to V by R. V is how much? 4 divided by R is 2. So this will be also 2 ampere. Clear? This is how you will solve the equivalent resistance for the infinite network. Okay. Next heading is the Wheatstone bridge. This is one of the most important topic of current electricity, and this is actually one method by which we can easily solve some difficult circuit. Look, if we give this type of circuit and the question is 2, 2, 4, 4. No, this is 4 you give, and this is 4, this is 2. Terminal is A, this terminal is B, and there is also one resistance which is 4 ohm. Now the question is find the equivalent resistance in between A and B. Okay, how to find? See, is it possible to find? Yes, it is possible to find if we disconnect the resistance from here. Then see, these two are series, then they are connected in parallel. Then we can easily solve. To solve this type of circuit, Wheatstone, he was a famous scientist, and he devised one arrangement by which we can easily find out the resistance of the conductor. This type of arrangement is called the Wheatstone bridge circuit. Take 4 resistance are so connected that as to form a parallelogram. Suppose a value of the resistance is R1, R2, R3 and R4. Okay. Now he told connect one galvanometer in one diagonal, and in another diagonal we have to connect a battery. See, here I am not connecting, I am connecting it outside. So this is same. And he told adjust the resistance in such a way that there is no current flows through the galvanometer. Again, adjust the resistance in such a way that no current flows through the galvanometer. And one thing we can say, when the current will not flow through the galvanometer, if the potential at this point I am giving, suppose A, B and P, Q. The potential at P is equals to the potential at Q. Then the current will not flow. If the potential is same, then how the current will flow? When there is potential difference, then the current will flow. Now see, if the potential difference is V over here, now we can write it is getting the potential V and difference is V. So we can write this is V, this is 0. So it is getting 0. Okay, just consider as the potential difference of the cell is V. We can say there is a certain condition under which the current will not flow through the galvanometer. That condition we have to find. So first to consider the potential at P and Q is same. By considering this, what is the condition that I will find? Now think about the potential at P is suppose M. So we have what we have taken? Potential at P equals to potential at Q. So potential at Q will be also M. Now see, the potential at A is V and at B is 0. So in between A and P there will be a potential difference. So that potential difference, before that, see, the current will flow from the battery, which is I. Here also I, it is getting two paths. So this will be I1, this will be I2. And as no current is flowing through the galvanometer, so we can consider this I1 is flowing through R2 also. Okay. And this I2 is flowing through R4 also. And which will make the value which is I. Clear? Now the potential difference in between A and P. See, here what I have taken M, and here also M I have taken. Clear? So V minus M, potential difference V, M, current is flowing through R1 from high potential to low potential, means this is high, this is low. That's why V minus M equals to I1 into V equals to IR. So I1 into R1. Now in this case, see, in between P and B, the potential difference obviously M minus 0 equals to I1 into R2. In the same case, give the equation number 1 and 2. Okay. Now in same case, in between A and Q, so potential difference will be V minus M equals to I2 into R3, which is equation number 3, and in between QM, again this is high, this is low, because the current is flowing from higher potential to lower potential. So this will be M minus 0 will be I2 into R4, which is equation number 4. So from 1 and 3, this is also V minus M, this is also V minus M. So we can write I1 R1 equals to I2 R3. So from here we can write I1 by I2 equals to R3 by R1. And the second case, from 2 and 4, this is also I1 R2 equals to I2 R3, means I1 by I2 will be this is R4 by R2. Okay. Now this I1 I2 and this I1 I2, this I1 I2 are same. So R3 by R1 equals to R4 by R2. From here we can write R1 by R3 equals to R2 by R4. So under this condition, we can consider the potential difference across these two terminals is 0, or the potential of the two terminal is same. If this condition holds, then we can neglect the resistance which is connected in between P and Q. So now this R1, R2 connected in series, R3, R4 connected in series, and they are connected in parallel. By easily we can find out the value of equivalent resistance. Otherwise, if one unknown resistance is connected, suppose this R2 is unknown, okay, but this R1, R3 and R4, these are known resistance. How to find R2? See, apply the value in this formula. So it will come R1 by R3 equals to, this is unknown, R4 is known. So from this formula we can able to find the value of R2 also. These are the application. Next I will show some problem. In some problems you will see there is one resistance, and if you see this R1 by R3 equals to R3 by R4, then you neglect this resistance because no current will flow through the resistance. Okay, now by one problem I will explain it. Okay, start with a simple problem. See, suppose the resistance is 5 ohm, whatever. These are 2 ohm, 4 ohm and 6 ohm, 3 ohm. See, here we can apply the Wheatstone principle, because this 2 by 4 equals to, this ratio is equals to 3 by 6. Otherwise, this 2 by 3 equals to 4 by 6 means that is also 2 by 3. Otherwise, 2 by 4 equals to 1 by 2 and 3 by 6 equals to also 1 by 2. So now we can apply the Wheatstone principle. Means we can neglect this resistance. No current is flowing. Now these two are connected in series, these two are connected in series. So the equivalent resistance will be 2 plus 3, 5 into 4 plus 6, 10 divided by 5 plus 10. This will be 50 divided by 15. Now solve it, no problem, otherwise you can keep it like that. Okay, the question is given how to find the equivalent resistance in between A and B, means find R net, where all the values are given R by 2. Look, here as this point is A, there is only where. So when only there is only where, then to consider this point and this points are same. So this will be also A. So we can say B, B, B. But this point and this point will be different because the resistance is connected. Same case will happen over here. So I am considering this point is P and this point is Q. Okay, and this will be Q also. Now draw the simplified circuit over here. So we are getting A, B and P, Q. Now look, this R by 2 is connected in between AP and this R by 2 PQ. Okay, now this one, this is also A to Q, A to Q. Now this one A to B, A to B, okay. But there is no connection, that's why I give the sign like this. And this is P to B, P to B, Q to B. Okay. Now see, if we consider this resistance is not there, then these 5 actually are forming a Wheatstone based circuit. Then we can neglect this one. And before that you have to check the ratios are same or not. See, R by 2, R by 2, same. So we can consider this is a Wheatstone based circuit. Now the total will come, means the equivalent will come, this R by 2 are series. So the total resistance will be in series connection, R by 2 plus R by 2 will come. This is R, I am telling RS1 equals to, this will be R. And here this will come also R, means the, and this is R by 2 also. So here the net circuit will be R by 2, and this is R, A and B. Now they are parallel, so we can apply the equation 1 by R equals to 1 by R plus 1 by R by 2 plus 1 by R. So this will be R and 1 plus 2 plus 1. So this will be 4 by R, means R equals to R by 4 ohm. This is the resistance. This is how we can calculate the equivalent resistance in between two. How to solve this type of circuit? See, here as this point is A, this is also A. This point is B, this point we can consider B. But here the resistance is connected, so we can't consider these are the same points. So here I am giving it P and Q. So we got A, B, P and Q. 4 points we got. See, this R is connected in between AP. Okay. This is PQ. Okay. AQ. Simple. PB. Now here PB, which one? PB. Now QB. Okay. Now see, these are forming a Wheatstone based circuit and the ratios are same, so we can consider this is a balanced Wheatstone based circuit. Under this condition, R by 2 equals to R by 2. R by 2 by R by 2 equals to R by 2 by R by 2, means 1. Now the equivalent R will be, see, these are connected in series. R by 2, R by 2. R by 2 plus R by 2 means R. This is also R. So R into R divided by R plus R. This will be R square by 2R, means which is R by 2. Okay, clear? How to find the equivalent resistance in between A and B? Pause the video and try to solve it. Okay, let's go. See, this point is A, this point is B, means this will be B also. But here the resistance is connected, here also this point is A, this resistance is connected, so the point will be different. Suppose this point is X and this point is Y. Now we got 4 points, A, B, X, Y. Look, this R is connected in between A and X. Okay. Now this R is connected in between A and Y. Okay. X and Y. Now X and B. Here Y and B. Now look, it is easy. They are forming a Wheatstone based circuit. So the ratios are same. That's why you can neglect the resistance from here. So the net will be R by 2. R by 2 series. So this will be R, and this is also R connected in parallel, R plus R. So this will be R square by 2R, which is R by 2. Clear?